Good morning, friends and dear students. It gives me immense pleasure to be here again for my course Flight Mechanics. In the process of this course, I am at the last stage of this course where I have already completed my theory part, that is the module 1, which is Introduction to Flight Mechanics. In that we have the basics of aerodynamic topics like lift, drag coefficient, lift coefficient, pitching moment, then parasite drag, induced drag, drag polar, CD is equal to CD naught plus KCL square. Also in the first we have studied about the International Standard Atmosphere, ISA. In that troposphere, stratosphere, mesosphere, their change in the temperature, density and the pressure we have already done. In this process we have also gone through the different air speeds like true air speed, equivalent air speed, calibrated air speed and indicated air speed and their relations with all the speeds. We have also done with that. If you talk about the module 2, we are learn about cruise performance. In that we have seen the equations of motion. In equations of motion we have seen that lift is equal to weight and thrust is equal to drag for steady cruise flight. In that case we have also find out the thrust required, power required, thrust available, power required, available, excess thrust, specific thrust, range, endurance. These all things we have already derived the equations, solved so many numericals and all. If you talk about the module 3, we have done about the climb performance, and we know that climb performance is the performance in which the aircraft is gaining the altitude. Kinetic energy is converted to the potential energy. Altitude is increasing like this. We have seen what is the maximum climb angle, rate of climb, minimum drag velocity, minimum climb velocity, rate of climb, range of the climb, horizontal and the vertical distance travelled. 3:1 formula for the descent and the climb. We have also gliding and the descent flight we have already covered. If you talk about the module 4, we have maneuvering flight, that is the accelerated flight. In that first we have the coordinated turn. Aircraft has to go in the same plane and turning. That is called the coordinated turn. And then we have the pull-up maneuver. In that, in the vertical plane, aircraft is moving. We have done all these equations. Then load factor, radius, time, angle of travel. In Venn diagram, we have seen the lines, aerodynamic lines, structural lines, maneuvering point, stall point, stall speed, VNE, never exceed speed. These all things we have covered in our module number 4. If you talk about the module number 5, we have the landing and the takeoff performance, fuel calculation, different types of fuel, reserve fuel, emergency fuel, contingency fuel, bulk landing. All this we have already covered. Today I am on the definition and the terminology of my module 5, which is the takeoff and the landing performance. I am Dr. Yagya Dutta Dwivedi, professor from Institute of Aeronautical Engineering, Hyderabad, India, and I am from the Department of Aeronautical Engineering. Today's in my class I will be defining terminal phase, define takeoff, define landing, define ground roll, define flare, define climb, and also we will be undertaking some equations for the landing, takeoff and the landing. So definition and the terminology, takeoff and the landing. So define terminal phases. All conventional aircraft flight starts with the point of departure with a takeoff and end at the destination with a landing. These are known as the terminal phases. So if you take any aircraft, if you start from here, this is the takeoff, I write takeoff, then this is the climb, this is the cruise, this is the descent, this is the landing. So all climb, cruise, descent and landing. All conventional aircraft flight starts with the point of departure. So this is the point of departure and end at the point of destination. So this is the point of destination. Here you have the takeoff, then landing, then all phases are explained here. Define takeoff phase. So here is the takeoff from here. So the takeoff phase, aircraft of transferred from its stationary ground-borne state into a safe airborne state. So in the takeoff phase, aircraft of transferred from its stationary ground-borne state into a safe airborne state. So ground-borne to, it is here, it is from ground, it is starting to the safe airborne. Define landing phase. It is reverse of the takeoff. In the landing phase, the aircraft is transferred back from the airborne state to the ground state, to the ground state. So here you are this is the landing. So from airborne, here it is, and here is V is equal to 0. It is V touchdown. This is the V approach. It is 1.3 Vs, 1.1 Vs, and V is equal to 0. So these are the phases which are explained here. Define ground run distance. If you see here, the aircraft is in contact with the ground and its weight is supported by the landing gear. So if this is the runway, on the ground, this is the runway. So your aircraft is here. It is V is equal to 0 to V is equal to V takeoff. Accelerated here, this is called the ground run distance, and this is very much essential. After that it is ground roll, then it is climbing like this. So the aircraft is in contact with the ground. So here you mu r, friction force of the runway will be affecting here. The aircraft is in contact with the ground and its weight is supported by the landing gear. These are the landing gears. The wheel which is supporting on this thing, and total weight is supported by the landing gear. Here lift is not playing the role. Define airborne distance. So now here, from here to here, this is your SA. So the aircraft is in transition between ground-borne state and its safe airborne state. So from here, this is the airborne distance. Here, this one, it is SA. So it is fully clearing the ground, and as per this thing, it is 15 meter. If your, and how much your runway is required, that is called the airborne distance. Define engine failure accountability. The aircraft performance should be such that at whatever time an engine fails, including during takeoff, during forced landing, and should not be necessary. This is known as engine failure accountability. Define CTO, conventional takeoff and the landing. It is a simple and traditional way of landing, that is called the CTO. Define RTOL, reduced takeoff and landing. So in case of some emergency, aircraft has to reduce takeoff and the landing distance. Define STOL, short takeoff and the landing. So if this is your runway and there is some disturbance here, actually you need up to here, but you have to make some arrangement that your aircraft is taking off here itself. It is not reaching here. That is called the STOL, short takeoff and the landing, especially for shipborne aircraft carrier fighters which are used, short takeoff and the landing, reduced takeoff and the landing. These all terms are used for that purpose. CTO is a conventional takeoff and the landing. Normal runway is required. That is the best way. But in case of some emergencies, we need some reduced takeoff and the landing. We may have to reduce some weight of the aircraft, or we have to make some additional thrust to make this happen. And same way, short takeoff and landing can also be performed. Vertical takeoff and the landing, especially for the shipborne flight, the thrust of the engine, if this is the aircraft, this is the tail, and here we have the engine. This engine will turn the exhaust nozzles downwards like this, and your aircraft will be lifted up like this. Vertically, like helicopter, it will go. Thrust will go down, aircraft will go up. That is called the vertical takeoff and the landing. In Indian Navy, we were having the Sea Harrier aircraft that was able to take off vertically and it can go down. Landing and takeoff was performed by the help of the 4 jets. Define STVOL, short takeoff and the vertical landing as the same. Define minimum control speed and air speed below which the rudder will not be capable of providing a yawing moment large enough to provide directional control. So define minimum control speed. So the minimum speed at which rudders are not able to do its function properly, and air speed below which the rudder will not be capable of producing a yawing moment large enough to provide directional control. So in this speed the aircraft will not be able to yaw. That is the purpose of this thing. Define lift off speed. The speed at which aircraft is about to leave the ground. About to leave the ground, that is called the lift off speed. So if this is the runway, aircraft is starting from here. This is here. We lift off. From here, your aircraft will start like this. This is called the lift off speed. Define rotation speed. So after this lift off, aircraft will start rotating like this. Means one wheel will be touching another nose wheel will be up. It is from 1 to 3 seconds. This is called the rotation speed of the aircraft. The rotation speed must allow time for the aircraft to rotate into the lift-off attitude before the lift-off speed is achieved. So sometimes it will be going like this, and then like this in the runway it will be going like this. So it is a rotation speed. CL at lift-off, CLO. It is the CL of lift-off which is 0.7 of the maximum. So at CL lift of 0.7 of CL max. This is the standard formulation or standard experimental results they have concluded. STVOL we have already done, short takeoff and the vertical landing. Define minimum control speed and air speed below which the rudder will not be capable of producing a yawing moment large enough to provide directional control. Takeoff safety speed. This is the air speed at which both a safe climb gradient and directional control can be achieved. Define airborne distance. After liftoff, the aircraft is accelerated to the safe climbing speed as it is rotated into the climb. Define braking distance. Once the nose wheel is on ground, the aircraft can be deaccelerated to a halt in the raking speed, is raking distance. Runway condition. The effect of runway slope and the runway friction coefficient on the ground run distance can be accounted for by considering them as equivalent to an increase in the braking force. Now we will discuss the fuel planning. Fuel flight planning definition. Additional fuel. Additional fuel is fuel which is added to comply with a specific regulatory or the company requirement. So additional fuel which is carried with the regulatory body or the company as and when they want. Alternate fuel. Alternate fuel is the amount of fuel required from the missed approach point at the destination aerodrome until landing at the alternate aerodrome. It takes into account the required fuel for missed approach at the destination airport, climb to en route altitude, cruise and descent at the alternate aerodrome, approach at alternate, landing at the alternate aerodrome. So alternate fuel, if one aircraft is going from station A to station B, if you see that while approaching to the station B, you are on the landing approach and there is some problem on the runway, or ATC has informed that there is going to be some problem on the runway. So you have to see that the fuel is sufficient to land in another airport which may be nearby. So you have to calculate the missed approach, how much fuel is required, then climb to en route, then cruise to en route, then descend and again land. That much fuel you have to, alternately you have to carry, approach at alternate and landing at the alternate. This all things you have to count how much fuel is required. That fuel is called the alternate fuel. Ballast fuel, it is the fuel which is used to maintain the center of gravity of the aircraft within the limit. That is called the ballast fuel. Contingency fuel or the route reserve. Contingency fuel is carried to account for additional en route fuel consumption caused by wind, routing changes according to ICAO Annex 6. The recommended minimum contingency fuel is the greater of 5% of the trip fuel or 5 minutes holding consumption at 1500 feet above destination airfield elevation. Final reserve fuel, fixed reserve fuel and holding fuel. Final reserve fuel is the final fuel required to fly for 30 minutes at 1500 feet above the alternate aerodrome, or if an alternate is not required, at the destination aerodrome at holding speed in ISA condition. Some regulating authorities requires sufficient fuel to hold for 45 minutes. taxi and the trip fuel. Taxi, we know that if aircraft is on the ground, it has to taxi from runway to the airport launch, from airport launch to the runway. That is called the taxi. And in this taxi, how much fuel is consumed, and it is also how much auxiliary power unit is consuming the fuel. So taxi fuel is the fuel used prior to takeoff and will normally include pre-start APU consumption, engine start and the taxi fuel. Taxi fuel is usually a fixed quantity of an average taxi duration. However, local condition at the departure aerodrome should be taken into consideration and the taxi fuel adjusted accordingly. Trip fuel, burn fuel and fuel to destination. These are the same term. Either you say the trip fuel or the burn fuel or the fuel to destination. The trip fuel is the required fuel quantity from brake release on takeoff at the departure aerodrome to the touchdown at the destination aerodrome. This quantity includes the fuel required for takeoff, that is climb to cruise level, flight in level cruise, including any planned step, climb or steep descent, flight from the beginning of descent to the beginning of the approach, approach landing at the destination. Go around is an aborted landing. So what is the go around? So go around is an aborted landing of an aircraft that is on final approach. A go around can either be initiated by the pilot flying or requested by ATC for various reasons such as an unstabilized approach or an aviation. A go around is the aborted landing of an aircraft that is of final approach. A go around can either be initiated by the pilot flying or requested by ATC for various reasons such as unstabilized approach or an obstruction of the runway. Bark landing, a very important term. A bark landing is an easy, safe maneuver and it is the thing to do whenever you think it is appropriate. Bark landing. Aviation safety means the state of the aviation systems or a organization in which risk associated with aviation activities related to or in direct support of the operation of aircrafts are reduced and controlled to an acceptable level. It encompasses theory, practice, investigation and categorization of a flight failure, the prevention of such failure through regulation, education and training. Runway excursion, an incident involving only a single aircraft making an inappropriate exit from the runway. So if your aircraft is out of the runway, it is called runway excursion. Runway overrun, a specific type of excursion where the aircraft does not stop at the end of the runway. So this is the runway. It is landing from here and it is cross the runway here. So it is a overrun. Excursion incident involving only single aircraft making an inappropriate exit from the runway. So it is going and it is like this, like this. This is called the runway excursion. Aviation regulators, we have the Director General of Civil Aviation India, Civil Aviation Authority United Kingdom, Department of Infrastructure, Transport, Regional Development and the Local Government Australia, European Aviation Safety Agency ESA, Federal Aviation Administration United States, FAA, Federal Aviation Regulations, Irish Aviation Authority. These are the few regulators of the world, and we have in India we have the DGCA, which is under the Ministry of Civil Aviation. Transport, Canada. Important terms: NOTAM, notice to airmen, messages created and transmitted by the government agencies and airport operators to alert pilot of any hazard. If anything is, some testing is happening, this NOTAM is raised, and in that area no aircraft will be flying. MTOM is maximum takeoff mass, the highest mass allowed for an airplane to take off on an airport runway. ATOM, actual takeoff mass, the actual mass of the airplane when taking off. MLM is a maximum landing mass, the highest mass allowed for an airplane to land on an airport runway. ALM, actually landing mass, the actual mass of airplane allowed when landing on an airport runway. Leg, a route between two airports is called the leg. Trip kit, a document that is handed over to the pilot that contains all the information on the certain flight. We will be discussing now next topic, question discussion on the question bank, solutions, introduction of airplane performance. We will be again taking one class for each unit. Only 5 classes are left as of now. So this all 5 units will be recovered and lot of questions will be handled in these problems. References are Anderson J.D. Junior Aircraft Performance and Design, International Edition, McGraw-Hill's, first edition, 1999. Iselbai Emi, Aircraft Performance Theory and Practice, AIA Education Series, AIA. Any questions, you are welcome to ask. My email ID is yddwivedi@gmail.com. Please do like and subscribe my channel. Do not miss to press the bell icon. Do comment. If anywhere you have any problem or it is not explained properly, please let me know. It will be my pleasure to reply you. Till then, goodbye. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.